Assalamu alaikum dear students. Today we are going to discuss another type of sequence, that is geometric sequence or geometric progression. Let me consider a sequence whose first term is 5, second is 25, 125 and 625, so on. Clearly this sequence is not AP because the common difference is not same, because second term minus first, that is 25 minus 5, which is 20. Now 125 minus 225 is 100, so this means that it is not AP. Here the first term is 5, second is 25, third is 125, fourth one is 625, so on and so forth. That is, the terms in this sequence, that is 525, 125, progress in this form. That is, whenever we divide second by first, that is a2 by a1, which is 5, third by this second, that is again 5, fourth by third, that is 625 upon 125, it is again 5. This means that this sequence, that is 525, 125, progress in such a way that the ratio of the nth plus 1th term, n plus 1th term and the nth term is same, because here ratio of n plus 1th term and nth term, that is second term upon first term is 5, third term upon second is 5, fourth upon third is 5, and n plus 1th upon nth term is 5. This means that this sequence, the terms in this sequence progress in this way, that is ratio of the n plus 1th term upon nth term is same throughout, that is an plus 1 upon an is constant. Let me consider that constant to be r. R is here in this sequence, r is 5. Such sequences are said to be geometric sequence, or called as the geometric sequences, or simply geometric progression, that is GP. Here this constant ratio, that is r, this is called as the common ratio. Now this geometric progression or geometric sequence may be finite or infinite if number of terms is infinite or number of terms is finite. Now how to find write the standard form of this GP. Let first term of this GP is A, or is the common ratio. Then second term should be A or, because A2 upon A or should be R. This means that the A2 should be A R. Now third term should be A R square, because A3 upon A2 should be R, that is A R square upon A R should be R. Similarly, nth term should be A R raised power n minus 1. This means that the general form of this GP is A first term A R, second term A R square, third term A R raised power n minus 1, nth term. Now this is the standard form of this geometric progression, whose first term is A and the common ratio is R, which implies that the general term or the nth term of this GP is A R n minus 1. Now if we consider this expression as A plus AR plus AR square plus so on to AR n minus 1 plus so on, if the terms are infinite. Now if the terms are finite, then we have to stop up to AR raised power n minus 1 if it contains n terms. Now this expression is called as the geometric series, whether it if the given sequence is finite, then it is finite geometric series. Now if we have infinite this number of terms in this GP, then this expression, that is A plus AR square plus so on to AR raised power n plus so on, is called as the infinite geometric series. Now how to find the sum of the first n terms of this GP? Now if the given GP is AR square plus so on to AR n minus 1, whether it is finite or infinite, it depends upon the number of terms, then Sn means sum of the first n terms is a1 plus a2 so on to an. Here a1 is A, a2 is AR, so on to an is AR n minus 1. Now take n, this A common, because A is in multiplication in each term of this GP, which implies by taking A common we get 1 plus R plus so on to R raised power n. Now here we will consider the different cases. Now if r is 1 means common ratio is 1, then we get Sn as from first 1 a into 1 plus 1 plus so on to 1 n times. This means that it is simply Na. This means that when r is 1 means common ratio is 1, then the sum of the first n terms of Gp is Na or An. Now if r is not equals to 1, then by multiplying r in equation first, that is Rn plus A. Now when we multiply this r in LHS of this first RHS of this first equation, we get r plus r square so on to Rn minus 1 plus Rn, because here we have how many terms? N minus 1 term, n terms. This means that by multiplying r we get r up to r plus r raised to power n. Now subtracting equation the second from first. Now while subtracting equation second from first, we get Sn minus or Sn, because subtracting LHS firstly. Now this equals to, now here first term contains a plus a or so on to a or n minus 1 minus a or plus so on to a or n. So simply we will get, by cancelling the terms, we will get a minus a or n, which is a into 1 minus or n. So from this from LHS we should take this Sn common. We get 1 minus or Sn, which implies that Sn is a into 1 minus or n upon 1 minus or Sn is or a into or n minus 1 upon or minus 1. So this is the sum of the n terms of Gp whose first term is a and common ratio is r, which is not equals to 1. So this means that when r is 1, sum of the first n terms is Na, and when r is not equals to 1, then the sum of the first n terms of Gp is a into 1 minus Rn upon 1 minus r, or a into Rn minus 1 upon r minus 1. So in this way we find the sum of the first n terms of this Gp. So thank you.